The ability to cryopreserve sperm has revolutionized artificial breeding programs, as it allows breeders to extend the gene pool by sourcing sperm interstate or even internationally. It also allows for sperm to be stored indefinitely. Although the cryopreservation of sperm has a wide scope of applications, the process places sperm under substantial stress. It is therefore of paramount importance that the industry standard protocols are carefully followed. Prior to beginning the freezing process, be sure to assess the quality of the sperm pre- and post-dilution, as only top quality samples should be used. As mentioned earlier, the freezing process is damaging to sperm, and is only fruitful when good quality samples are used. The diluted semen needs to be cooled slowly prior to freezing, as rapid cooling will cold shock sperm. To slow cool, a beaker is filled with water at 30 degrees Celsius. The samples are then placed into this water jacket and put into a cool room at 4 degrees Celsius to cool over a period of 2 hours or until the samples reach 4 degrees Celsius. After this period, the sperm can then be frozen. There are two main ways to freeze semen, but the quickest and simplest is to freeze in pellets. In this method, semen is first frozen on dry ice at -79 degrees Celsius before being plunged into liquid nitrogen at -196 degrees Celsius. A special tool is used to make indentations in the dry ice. Only light pressure is needed to create indentations deep enough for freezing pellets. If freezing is not being conducted in the cool room, all equipment needs to be pre-cooled beforehand. 200 to 250 microliters of semen is aspirated and gently pipetted into the indentation. The pipette is only depressed to the first stop to avoid creating air bubbles in the pellet. It takes around 2 to 3 minutes for the pellet to freeze through. During this time, the pellet will turn from a glassy, vibrant liquid into a duller, matte solid. The frozen pellet is taken from the dry ice with pre-cooled forceps and plunged into liquid nitrogen for storage. Although individual identification of pellets is not possible, they can be stored in goblets. Goblets come in different colours and can be labelled. Pellets are placed into the goblet and secured in place by inserting a piece of gauze or cotton wool into the open end. Another main way in which semen is frozen and stored is through the use of straws. Freezing in straws is the preferred method of cryopreservation for commercial operations, as it easily allows for identification of individual samples. There are several different types of straws. This one comes sealed at one end with cotton wool and open at the other for the aspiration of semen. After the chilling period, a 1 ml pipette tip is fitted onto the end of the pre-cooled straw. A straw holds 250 microliters of semen, so to account for any loss of liquid, the pipette is set to just over this volume. The open end of the straw is placed into the sample, and the sample is gently aspirated by the pipette. To seal the open end of the straw, it is dipped in PVC powder and then into a beaker of water. On contact with water, the PVC powder expands and cements, creating a plug at the previously open end of the straw. Once the straw has been sealed, it is then ready for freezing. A metal rack is placed in the liquid nitrogen, so that the top of the rack sits 4 centimeters above the liquid nitrogen level. The straws are laid out horizontally on the rack to freeze in the liquid nitrogen vapor for 6 minutes. After this time, the straws can be plunged into the liquid nitrogen and stored indefinitely. Similar to pellets, straws can also be stored in goblets, which allows for additional identification. samples is conducted with strict adherence to industry protocols, as damage can occur to sperm during the thawing process if not conducted correctly. A small polystyrene box is filled with liquid nitrogen to transfer frozen samples from the storage tank to the laboratory. Pellets or straws are removed from the liquid nitrogen storage tank and immediately placed in the transfer box. Be sure to wear gloves, safety glasses, and enclosed shoes when handling liquid nitrogen, and ensure all handling is conducted in a well-ventilated area. In the laboratory, ensure that a water bath is heated to 37 degrees and all receptacles are labelled appropriately. To begin the thawing process, place a pellet into a dry glass tube and place the tube into the water bath. Shake the tube vigorously for 2 minutes to ensure even heating of the sperm. You may thaw more than 1 pellet per tube, but it is not advised to thaw any more than 3 pellets in a single tube. Straws are thawed in a similar manner by shaking in a water bath for 1.5 minutes. They are then dried, both ends of the straw are cut, and the sample is drained into a pre-warmed receptacle. Thawed samples from straws or pellets are placed in a water bath at 30 degrees Celsius for the duration of processing and assessment. Once thawed, it is important to conduct a post-thaw assessment of the sperm to determine that the sperm have not sustained any substantial damage during the freezing or the thawing process. It is helpful to cross-check the samples against their pre-freeze parameters.